introduction, Youth. And I want to thank the audience too. As I said, I put it on my Facebook, so I see quite a few colleagues from Department of Communication, as well as communication scholars from other universities in the audience here, in addition to our usual audience to the TAMIDS seminar. So I just want to say thank you for coming, and I hope you will find this talk useful or interesting. So today my talk is studying risk and crisis communication during emergent infectious disease outbreaks from social media, big data. I have been studying emerging infectious disease since 2015, the year when we had a big measles outbreak in California. So emergent infectious disease is a term that we use to refer to new new infectious diseases, such as newly identified species of pathogens, such as Zika virus, COVID, or pathogens affecting, an original population, but now jumping to another population like the West Nile virus, bird flu, swine flu, SARS. It sometimes is also used to refer to drug-resistant bacteria, that is the superbug, or re-emergent infections such as measles, which was declared, eliminated in early 2000, but is coming back. So what these variety of illnesses share is their newness and a high level of uncertainty about the risks that we face during these EID outbreaks, and how to deal with these unknown, new, and evolving risks. For instance, COVID-19, we all personally experienced the novelty of the pandemic, the uncertainty about the causes, the spread, the prevention of the illness, and one day mask is not useful, another day it's useful, then it's not useful again. So that is just the nature of emergent infectious disease. That is super interesting. So I approach the study of emergent infectious diseases and social media through a number of theoretical approaches. I took the approach of risk and crisis communication, for instance, which basically talked about how do the government or public health agencies or experts use social media to communicate EID-related information to the public. I also conduct research on people's information seeking and information sharing on social media during COVID, during emergent infectious disease outbreaks. For instance, how do social media users access, process, and share information about the illness and about their personal experiences? And the last general approach that I took to EID and social media is misinformation. I'm interested in how are the public exposed to misinformation on social media, and how do they process such information. So today I will briefly share with you 3 studies that I published last year or this year. Very briefly on each of these 3 directions to give you an idea of my ongoing research. And then the goal is to identify opportunities for collaboration. And hopefully, if you find something interesting, let me know. I'm very open to future collaboration. The first study is in the first study, I look at how public health agencies and emergency preparedness organizations in the state of Texas use Twitter for crisis and risk communication. Research on the function of organizational media use typically identifies 3 functions of social media use. information, that is to provide people with information about the illness or the outbreak. Action is where they can use social media to encourage certain behavior or discourage other behaviors to promote prevention. And community refers to when organizations use social media to build relationships with community stakeholders, to build relationship and social support. So the first thing that I wanted to look at was did the Texas the public health agencies in Texas fulfill these different functions in their social media and Twitter content in more specifically. Another theoretical background that I drew upon was the health belief model, which is psychological theory that talks about how different health beliefs influence our attitude towards a certain illness or prevention behavior, which then in turn will influence our behavioral intention, that is, I plan to do this, and our behavior, that is, actually, I did this. So the 5 beliefs are susceptibility, which is how likely I'm going to get ill. Severity is how bad it is going to be if I get ill. Benefit is what are the advantages or the effectiveness associated with a preventative measure. Barriers are what are the barriers to the measure? Like, do I have access to the masks? Do I have access to the vaccines? And finally, self-efficacy is this belief in the confidence that individuals can perform the recommended behavior. So to understand, we want to see if Texas public health agencies do promote these different health beliefs in their messages. And also we want to look at how different message characteristics lead to the public engagement or the virality of their posts. So we identified all the public health agencies in Texas and those with a Twitter account and downloaded all their tweets related to COVID during the first 6 months of the outbreak. So it's a bit old now, the data. So we used BERT to identify, to run 3 types of classification tasks. The first one is function of the message, information, action, and community. The second is we also identify and classify what are the behaviors that they recommended. And the next one, we classify the health beliefs, that's severity, susceptibility, benefit, barriers, and self-efficacy from these Twitter tweets. So just very briefly, the result, you can see, the information function is obviously the most dominant function, followed by action, the purple line, and then the least dominant one is community. And in terms of behavior recommendation, the most frequently recommended behavior is to learn more about it. So then another one is stay at home and other behaviors. And again, this data was collected early on during the pandemic. So you can see that, for instance, mask and face covering was very, very low. They don't recommend it. In terms of we also coded the health belief models, health beliefs that are present in these posts. And we run a regression analysis to look at the association between the feature of the message and public engagement, which was measured first in the number of retweets and second in the number of likes, which signify endorsement. What we found out was that tweets that fulfill the function of information and action are more likely to be retweeted and information, tweets containing severity and susceptibility are also more likely to be retweeted. However, in terms of endorsement, that is the number of likes, then people tend to respond more favorably to messages fulfilling the function of community building, that is reaching out to community members to offer support, to build relationships, but they are not likely to retweet it. So this is a very quick overview of this study. And in another study, I was interested in looking at how are social media users exposed to vaccine misinformation. And this study was published in 2001, but the data was actually collected before COVID. So I just want to put it out there because after COVID happens, YouTube actually made some changes to their recommendation algorithms. So in this study,
Lou, there's some question in the chat. Do you want me to read that chat to you, or you can see the chat yourself?
Can I talk about that later? Like
yeah, you can do that at the end of the talk too.
Yeah, well, Sandra, I will address this later if it's okay. Thank you. So when we use social media, we feel like we have control over what we see. However, we don't have that agency that we thought we have, because researchers, especially researchers of communication and social media, have identified different mechanisms through which our exposure to information on social media are predetermined or are biased. The more common one is the echo chamber effect. That is, we are more likely to read what our friends post on social media, and we're more likely to be friends with people who are similar to us. And then they are, so this is called the law of homophily in network analysis. And as a result, we are more likely to be repeatedly exposed to the same information again and again that are from our friends or friends' friends. So this is called echo chamber. So we are unlikely to get very different information through social media. The second mechanism is called the filter bubble, which basically says our exposure to social media content is influenced by or decided to a certain extent by the recommendation algorithms of those social media platforms. And then their goal is to keep us there as long as they can. So they're just going to constantly recommend to us the kind of information that they think we're gonna to like or be interested in. This creates a filter bubble. Again, we're constantly, repeatedly being exposed to the same information. So this is what we want to test in the context of vaccine misinformation on YouTube. We looked at two ways in which people use social media, YouTube specifically. The first one is called what we call goal-oriented browsing. That is when you open up YouTube website and you plug in some keyword like COVID-19 or measles or I don't know, Texas A&M, and you see what's recommended on the search result. And then, well, a lot of times we do that, but even more often we do not go to the YouTube homepage. Instead, we access YouTube content by clicking on a video our friend post on another social media platform like Facebook or Reddit or LinkedIn, for instance. So you see, in that case, then you watch the video that your friend recommended to you, and after that, YouTube again is going to give you a set of recommendations based on this click. So we want to look at when YouTube users start their viewing with pro-vaccine or anti-vaccine keywords or an anti-vaccine seed video, to what extent will they be exposed to pro and anti-vaccine content? So this is from the perspective of individuals. How likely are we going to be exposed to pro and anti-vaccine videos if we start with pro-vaccine keyword pro-vaccine, anti-vaccine keyword or anti-vaccine seed video. That seed video refers to the situation where you click on a video that your friend recommend on another website. So the second research question is that we want to look at the relationship among different videos that's being recommended, or the network exposure. So what is the degree of exposure of pro and anti-vaccine videos, as well as other videos unrelated to vaccine, to additional anti-vaccine videos? So in this little figure, you can see that video A is not exposed to any pink video, which is exposed nodes. So the network exposure is 0. However, video Z, 4 out of the videos, it is related to 3 of them are anti-vaccine videos. So the network exposure is 0.75. So we collected data to mimic goal-oriented browsing as well as direct navigation. For goal-oriented browsing, we identified the most popular hashtag pro or anti-vaccine during that time of data collection, and use this search keyword to search on YouTube. And then we included the first 6 videos that are recommended. And then for these 6 videos, we go to the 6 most recommended videos for each of them. And then we go on another level. We went on 3 levels to mimic, again, people's exposure. We didn't go beyond 6 because we figure, people are lazy, and we usually just will click on the recommendation on the first page. Similarly, for direct navigation, we used 2 sets of anti-vaccine seed videos. One of the playlist was based on anti-vaccine conspiracy theory. The other one list was based on anti-vaccine expert on YouTube. So in doing, we identified and downloaded those videos, and then we manually annotated them in terms of whether they're related to vaccine, whether they're related to autism, is it health related, is it pro or anti-vaccine, and what are the sources of the video, so basically who made it. So in the end, we were able to create 4 networks of exposure networks, so pro-vaccine search keyword, and search network, anti-vaccine search network, vaccine conspiracy seed network, and anti-vaccine expert seed network. And then in these networks, you can see the green circles represent pro-vaccine information, and the red ones represent anti-vaccine videos. And just by looking at these 4 graphs, you can see that the seed network, you are much more likely to be exposed to anti-vaccine information in seed networks, but you are very unlikely to be exposed to anti-vaccine misinformation in search networks, even if you start with anti-vaccine search keyword. And then the reason is probably because even before COVID, YouTube was actively suppressing the ranking of anti-vaccine misinformation to some extent. And then you can see in this chart table, like of all the vaccine-related videos in each of these 4 networks, 63% of the videos related to vaccine in the anti-vaccine expert seed network are anti-vaccine, in fact, and more than half in the conspiracy seed network are anti-vaccine, and the number is much lower in the search networks. Doesn't matter if you use pro or anti-vaccine search keyword, which basically says that you are more likely to be exposed to anti-vaccine misinformation if you click on an anti-vaccine video that your friend posts. You have a very high chance. And we also calculate the network exposure model, which have similar results, which says that the red ones here means a significant odds ratio in two seed networks. Any vaccine videos are more likely to lead you to anti-vaccine videos, and in the anti-vaccine expert seed video network, even other health videos are likely to lead to anti-vaccine videos. And health misinformation lead to more anti-vaccine videos. Okay, so this study shows that we are more likely to be exposed to anti-vaccine misinformation when we start from a seed video and click on some of the recommendations as compared to if we just type in the search keyword in the homepage of YouTube. And it also shows us that vaccine misinformation begets more misinformation. Once you're in the rabbit hole of vaccine misinformation, you're unlikely to get out just based on what YouTube tells you to watch. And then later, a student of mine said she wants to look at the Arabic language YouTube to see if it is the same, because she says that in the Arabic world, people's idea about vaccine misinformation is different. There are not that much misinformation, or there are not much vaccine conspiracy theory. So she replicated the study in Arabic YouTube, and then the result is a little bit different. And then you can see that the pattern that we found in the English language YouTube is only found on the anti-vaccine expert YouTube network. But again, her study was done after COVID, so there might be some historical differences there. And then the last one, okay. This is a more recent study, just got published this year. This is a fun little project that's not theoretical at all. We're just curious about if we can use machine learning to identify vaccine adverse event from social media data. So vaccine adverse event means when you get the COVID vaccine and you feel like a fever, you're having a fever, or it hurts, your arm hurts, or you feel any discomfort. A lot of times people go to social media to talk about it. And in the past, researchers have been using social media data to monitor the adverse event of new pharmaceutical products like drugs, or sometimes we use social media big data to monitor the spread of infectious disease like flu. We can monitor like the spread of flu, this wave of flu or COVID or any infectious disease, just by looking at how often people talk about their symptoms on social media. So in this study, we want to do that with the social vaccine adverse event from social media data. So again, we collected Twitter content related to COVID. We used manual coding and machine learning to identify tweets that are reporting personal experiences instead of talking about COVID adverse event, vaccine adverse event in general, or talking about the adverse event of other people, like, my friend so-and-so did this, got this. And then we used named entity recognition to identify a set of COVID-19 vaccine related adverse event, and then automatically classify the all the tweets that we collected. So so this is just a little overview of the results. And on the left-hand side, this the darker the color, the more frequently people talk about vaccine adverse event, or it's just because there are more people getting vaccines in those states, or just because there are more people in those states. So we found that, yeah, the 4 states with the most discussion about the vaccine adverse event are California, Texas, New York, and Florida, which happen to be the 4 most populous states in the country. And longitudinally, the the blue line represents the number of tweets containing a vaccine adverse event, and then the red line represents a number of new vaccinations that we got from the One World database. And then we didn't run any fancy statistical analysis, just look at the longitudinal data. We can see some kind of correlation there. And then in terms of the most frequently mentioned vaccine adverse event, we compared our result, the adverse event reported on Twitter, to the top 10 adverse event reported to VAERS, that is the governmental portal, which where people can go and report their negative, their adverse event after COVID-19 or any other other kind of vaccine or drugs. So if you look at the left-hand side, you can see we look at Pfizer, Moderna, and Johnson & Johnson. And you can see like for Pfizer and Moderna, they're very, very similar. The side effect most talked about on Twitter is sore to touch, followed by fatigue, followed by headache, followed by chills, and then followed by fever, etc. and etc. However, on Johnson & Johnson, which is a different kind of vaccine, people report different adverse events. So headache and fatigue are the two most common, frequently reported, followed by sore to touch, chills, and fever. And then we compared our result with the result again from the governmental data. And we found that sore to touch is not a adverse event included in the governmental database, just because it is so minor, like nobody would bother to report it to the government, but then they can complain about it on social media. So it is likely that we can better capture these minor side effect, adverse event on social media. But then social media is less sensitive to serious side effect. If someone is seriously ill or hospitalized after vaccine, and they're probably not going to post a complaint about it on social media. So
can I ask you a quick question here?
Yes.
So is the sore to touch one option included in the government survey, or it's not really included there? So when you have ABCD, you can select it, but that's not the option you can select. Or it is option, but people don't select. I don't remember, because I submitted the feedback, but I don't remember what's the option given to me.
Okay, I need to double check, but off the top of my head, I think it is one, but people just don't bother. Because if you only have sore to touch, you're not going to get to the government portal to report it, but you can complain about it on Twitter. You only go to the governmental website to report for more serious side effect, but I can be wrong because my student did the creation of these categories. So
I don't think I really go to the website. I think it's after you take the, you had the vaccine, they send you the text message.
There are a number of ways this governmental portal is operated. You can report it, or the public health agency can send you those follow-up surveys, or your doctors can also report cases. So it comes from a variety of data sources. Okay. So yeah, thank you.
Thank you.
So yeah, this is just a fun little project to see how people are sharing their personal experiences about COVID-19 vaccine and the adverse event on social media. So Okay, so wow, I'm very fast. So basically, these are some of the newer studies that I have done with my students and collaborators in an effort to understand the role of social media during public health emergent crises such as emergent infectious disease outbreaks. When I first started to study this, it was in the context of measles. So measles is still primarily an illness that affects young people, and despite its resurgence, it only has it's very limited in its scope. So I never thought, there will be this COVID that's coming along that really, makes this kind of study more important. And I feel like when even now COVID, some people argue that COVID is going away, hopefully, there will be emergent infectious diseases that are coming up in the future because a lot of the emergent infectious diseases, they just jump species because wildlife, they don't have their habitat anymore. We're in closer and closer contact with those wildlife like cats, some kind of cats, bats, so there will be additional new infectious disease that are coming up in the future. So it is really important for us to use the COVID as a case study, as a context to really understand the role of social media. How do people talk about their experience, share information about infectious illness, emergent infectious disease on social media? How can the government use it to spread, for risk communication purpose? That is to tell the people, the public, what are the risks. In some other study, I even studied how government use social media for crisis communication. Crisis communication is a concept from public relations. So I look at, for instance, how government of China use social media to repair its image, to create this idea that we're a competent government who successfully controlled COVID for its own legitimacy purposes. So it is also important to look at the creation and spread of misinformation regarding emergent infectious diseases on social media. There has been a lot of controversy regarding the role of social media like YouTube and Facebook during the COVID-19 pandemic. So they have the incentive to promote alarming, brand new, controversial information, because then that leads to more clicks and more advertising revenues. But I believe that it is also their responsibility to really keep an eye on how they use their recommendation algorithms to promote different types of vaccine misinformation. And I think, after this study was published, it was cited by the Surgeon General of the United States in his vaccine misinformation report. So, and some news journalists said this was the reason why YouTube later was actually adjusting their their recommendation algorithm. They're doing more labeling. They're not only taking down more anti-vaccine videos, but also doing more labeling, as well as adjusting the recommendation algorithm regarding vaccine misinformation, so that persons like you and me, don't not get into the rabbit hole of misinformation, on YouTube. So that is basically what I have prepared for today. Now I am ready to